All right, hi everybody. Sorry that it's so late. Just had some other things I had to take care of, but here we are preparing for your quiz tomorrow. Okay, so number one, I'm looking for Newton's laws basically defined. Is this gonna let me edit another piece of paper or no? Okay, I guess I'm just gonna have to like write like below it. Okay, so let me get a blue color. So, oops, what is going on? Okay, law number one. Okay, this is his law on inertia. So what it says is an object at rest will remain at rest while an object in motion will remain in motion at constant velocity in a straight line. Oh wow, duh, that's not even one word, so let me fix that. Straight line unless acted upon by an unbalanced force. So yeah, this is a big chunky one, okay? Someone said, well, what if I don't write that it's going to stay at constant velocity in a straight line? Well, then that's wrong, because if you don't dictate that it's staying in a constant velocity and it's moving in any other way other than a straight line, if it's doing any sort of curvature, then unfortunately there is an unbalanced force acting on it, okay? So again, this is mandatory. Oof, that's terrible. Hold up. I don't even know what to write over it. Oh, that's like super, hold on. Let me see if I get this. Wow, that does absolutely nothing. Nope, I don't want the same color. Yeah, sure. I mean, that's still terrible. Okay, so you need the straight line and you need it at a constant velocity in your definition, okay? Law number two kind of goes right into this a little bit. So law number two can be written in two different ways. You're either writing that an acceleration is the result of an unbalanced force, or you're writing an unbalanced force is the result of an acceleration. It's either one or the other. You do not write both of them. So whichever one is sticking in your brain, that's what you'll write down. Basically, a mathematical way is F equals ma, but tomorrow I'm looking for you to explain by using one of these formats. Like, I want you to be able to describe in words what F equals ma actually means. And then law number three. Every action has an equal and opposite reaction. Okay. If we go back to that sheet, it then says using Newton's first law, explain why we wear seatbelts. So as you know, you want to continue moving in a straight line. So what's the job of the seatbelt, right? It catches you and prevents you from continuing your motion in a straight line. Right? Because that's what we know objects want to continue doing. According to Newton's first law, unless there is this unbalanced force, well, I'm going to continue moving forever and ever and ever at a constant velocity in a straight line. And so that seatbelt is going to protect you by catching you and preventing you from continuing your straight line path. Okay? All right. Then it says, using Newton's second law, justify whether or not objects at rest or moving at a constant velocity in a straight line can be experiencing an unbalanced force. Well, Newton's second law straight up says unbalanced forces only happen due to accelerations. Okay? So if you're not accelerating, right, because you're either moving at a constant velocity in a straight line or you're at rest, you cannot be in overlapping conditions, right? So you cannot be at rest and accelerating, or at CV in a straight line and accelerating, right? You cannot be overlapping. So because of that, and because we know unbalanced forces happen only when objects accelerate, that means if you're at rest or at CV, again, in a straight line, that's a very important detail, then no, you do not experience unbalanced forces. Again, to really reiterate, Newton's second law says an acceleration is the result of an unbalanced force or vice versa. So clearly you can't have an unbalanced force and then be in a condition other than something that's accelerating. Okay? Then it says, provide an example of Newton's third law. We did a lot of these in class. Literally, you sitting on a chair, standing, a swimmer pushing off the wall, books laying on a desk, recoil of a firearm, let's see, a rocket launch. Oh no, what the heck is happening? Oops. Rocket launch. So like anything, any one of these, you could obviously come up with your own too. Anything like that. Okay. All right. State which conditions are out of the three. I spelled accelerating wrong. LOL. Okay. So obviously, I can't write on this. Can I write over here? Oh, I can't even write over there either. Terrible. All right. So it says which conditions result in unbalanced forces. Okay. So we obviously know balanced at this point is at rest and at CV in a straight line. And then unbalanced, according to Newton's second law, is just acceleration. If I go back up there, then it says state how you know from the free body diagrams that the forces acting on the object are either balanced or unbalanced, right? So if it's unbalanced, that means that one force is bigger than the other, right? So they're not equal in length. Whereas, if you're experiencing balanced forces, all forces are the same length. Because we're saying that they're equal in magnitude. Okay. And you can literally see that on the diagram. They're the exact same length. Whereas if the object's accelerating, obviously one of those forces is going to be much bigger than the other. Okay. And then you're asked about your free body diagrams. So we're going to just draw those really quick and then we're going to call it a night. Okay. So for at rest, we're not talking about static or kinetic friction. So what I just expect from you, and I'm going to tell you that on the quiz, is I only want to see the normal force and the force of gravity. So I have my object on the flat surface, my dot in the center, Fg pulls down, Fn pushes up. Do your best to showcase that the normal force is equal to the force of gravity, right? You're going to do the best you can while drawing that. If you're constant velocity, okay, so again, my object on a flat surface, let's say that we are moving to the left. Okay, still I'm on a flat surface, so I have the force of gravity pulling me down, and I have the normal force pushing me back up. Because I am moving to the left, I know that my applied force is going to be to the right, and that my force of friction has to, my applied force is to the left, and my force of friction has to be to the right, because friction opposes motion. Okay, so again, friction opposes motion. So in this case, not only is the normal force equal to the force of gravity, but the applied force is equal to the force of friction, right? So at this point, we say that F net is equal to 0 newtons. Same thing over here. The net force in the vertical direction is also equal to 0 newtons. Whereas if I was accelerating, again, I'm going to have my flat surface. Again, gravity pulls us down. The normal force pushes us back up. However, let's say I'm going to be, accelerate, I'm going to speed up. So I speed up to the right. So my applied force, Fa, will be much greater than my frictional force. Remember, whatever side has the bigger force, that's the side the acceleration follows in. But writing the acceleration is not mandatory, right? This is not mandatory, and neither is this. A free body diagram is simply a diagram in which you're showcasing all the forces acting on the object. So again, Fn still equals Fg, but now we're saying the force applied is greater than the force of friction, and therefore Fnet cannot equal 0 newtons anymore, okay? Likewise, obviously we know that the acceleration also cannot be 0 meters per second squared. So hopefully this helps you. This is literally what you're going to have to do tomorrow. If you watch this video and I think that you've been practicing regularly and you have, gone through your notes and maybe did some studying on your own, I think you're going to be fine. Okay, so best of luck.